Hello all. So this video explains how to do the third question of the first classical mechanics homework. So part A wants you to be able to prove this relationship, which basically says that the dot product is distributive. So I think in the homework question itself, the little dot product symbol does not appear in between these vectors here. But if you ever see two vectors multiplied together without a symbol in between, it's going to be the dot product. So to start this question, I'm going to start out with the left-hand side of the expression and work towards the right-hand side. You could also start with the right side and work towards the left-hand side if you wanted. So the first thing I'm going to do is, since these are vectors, and I'm just going to assume they're three vectors, meaning each vector has three elements, I'm going to write it out in component form. So instead of R, I'll have R1, R2, R3, and that will be dotted with the U vector expanded would be U1, U2, U3, plus the V vector expanded V1, V2, V3. You could also use X, Y, Z if you like, instead of 1, 2, and 3. And so now that it's in component form, what I'm going to do is I'm just going to gather all the components that are the same together. So all the 1 components, all the 2 components, and all the 3 components. So if I do that, I get R1 times U1 plus V1 plus R2 times U2 plus V2 plus R3 times U3 plus V3. So R1, R2, and R3 are now just real numbers. And we know that real numbers are distributive. So I can distribute this R1 to the U1 into the V1, this R2 to the U2 and to the V2, and this R3 to the U3 and to the V3. So if I do that, I get the following terms. So R1U1 plus R1V1 plus R2U2 plus R2V2 plus R3U3 plus R3V3. So now, since all these terms are added together, I can sort of rearrange them and group them in any ways I like, and it'd still be the same expression. So what I'm going to do is I'm going to take these 3 terms with U's in them and group them together. And I'm going to take these 3 terms with V's in them and group them together. So if I do that, then I get the following. R1U1 plus R2U2 plus R3U3. So that is just the yellow terms I highlighted above, just grouped together, plus R1V1 plus R2V2 plus R3V3. And that is simply the green terms I highlighted above grouped together. But now look at what we have. R1U1 plus R2U2 plus R3U3 is simply the dot product of vectors R and vectors U. And add that to the green term, which is simply the dot product of vector R and vector V, I end up with R dotted with the sum of vectors U and V is simply the dot product of R and U plus the dot product of U and V, which is the identity I was trying to prove. So now there are a few other ways to prove this that don't involve breaking up into components, but I think this is one of the easier ways to do it. So moving on to part B. Part B wants you to prove that the product rule also holds for the dot product. So similar to what I did with part A, I'm going to start with the left-hand term and prove that it's equal to the right-hand term. You could also do this backwards by starting with the right-hand term and showing that it equals the left-hand term. And just like I did with the first one, I'm going to rewrite this in terms of vector components. So for R, I'll have R1, R2, R3, dotted with S1, S2, and S3. And I know what a dot product is, so I'm just going to go ahead and fill that in. So I'll have d dt of R1, S1 plus R2, S2 plus R3, S3. All right. And so a derivative, which is what this dt represents, can be distributed amongst sums. So I can write this as d dt of R1, S1 plus d dt of R2, S2 plus d dt of R3, S3. So now remember that R1, R2, R3, and S1, S2, and S3 are real numbers. And we know that the product rule applies to real numbers. So applying the product rule here gives me that R1 times the derivative of S1 plus S1 times the derivative of R1. So that would be what this first term equals. And then I'm going to add to that the second term, which you do a similar expansion for. So R2 derivative of S2 plus S2 derivative of R2. So that is simply this term with the product rule applied. And now finally, the last term gives you that the derivative of R3 times S3 is R3 times the derivative of S3 plus S3 times the derivative of R3. And so just to finish the color coding, this last term here gives this. And so since I now have sort of 6 terms added together, I can group these in any way I like. So my choice is going to be to gather these 3 terms that have an R out in front together, and then to get these 3 terms that have an S out in front together as well. So I want to change this to 2 groupings instead of 3. So if after I do that, I get that R1 times the derivative of S1 with respect to time plus R2 times the derivative of S2 with respect to time plus R3 times the derivative of S3 with respect to time is 1 grouping. And then I'll add to that S1 times the derivative of R1 with respect to time plus S2 times the derivative of R2 with respect to time plus S3 times the derivative of R3 with respect to time. But these terms, which I have 1 and 1, 2 and 2, 3 and 3, those just look like dot products. So I can rewrite this first term here simply as the vector R dotted with the vector I get from taking the derivative of the vector S plus, so this is a number and this is a number, so I can switch the order if I like. So that would simply give me the derivative of the R vector dotted with S, which is what I was trying to prove. So that's how you can prove the product rule also holds for the dot product. So if any of this was unclear, please feel free to ask me, Morten, or Jeremy, and we'll do our best to clarify any misunderstandings you still have.